Good morning, student. I welcome you all for this session. So, in the previous class, we have studied the type 1 problems, that is a doubly reinforced beam, how to find out the moment of resistance. Okay, those problems are type 1 problems. Now, let us see same doubly reinforced beam, but type 2 problems. Okay, so in this type 2 problems, the given data are, so the factored moment will be given. Okay, either mu will be given or m will be given, that is moment of resistance, or factored moment mu will be given, or if they don't give mu or m, they will going to give the total load with span and type of support. Okay, so span will be given, total UDL will be given, and type of support, it is whether it is simply supported beam or a cantilever, will be given. So from this we will going to calculate mu or m. Okay, then size of beam will be given, that is the dimension of beam will be given. Then as usual, grade of steel and concrete will be given. Okay, then what is the required? Okay, so these are the given data, right? We have to calculate area of tensile steel, that is AST, and area of compression steel, ASC. Okay, so we have to calculate AST, that is bottom steel, and ASC, top steel, that is compression steel and as well as tensile steel. So in the first type 1 problem we have calculated this, but in second type problem, right, mu or m will be given, then we need to calculate AST and ASC. So this is the type 2 problems. Then what are the steps to be followed in this type 2 problems? So step 1 is, okay, if directly mu or m is not given, right, if the load is given, okay, total load is given, that is w, small w, that is UDL will be given, and effective span of the beam will be given. Then so using these two data, first we will going to calculate maximum bending moment. Okay, calculate maximum bending moment. Okay, so depending upon the type of support. Okay, so if it is a simply supported beam with carrying UDL, then the maximum bending moment at the center, it is WL square by 8. Okay, small w L square by 8. So this is a maximum bending moment for simply supported beam carrying UDL. If it is a simply supported beam with UDL, then maximum bending moment will be calculated as m is equal to WL square by 8. Okay, this is m, not mu. Okay, m is equal to WL square by 8. Then if it is simply supported, if it is a cantilever beam with same UDL, then m is equal to maximum bending moment, okay, is equal to WL square by 2. If it is simply supported, it is WL square by 8. If it is a cantilever, it is WL square by 2. Okay, so see the condition given. If it is a simply supported or cantilever, so depending upon the condition, we need to use any one of these to calculate the maximum bending moment. So this will give m. Okay, but we want factored moment, mu we want. So directly whatever the m you will going to get, multiply 1.5. Okay, so factored moment mu is equal to m into 1.5. Okay, so we'll get directly factored moment. So this is the first step. Okay, see the condition of the beam. Okay, then use any one of this to find out m, multiply 1.5, you will get mu. Okay, then the second step. So once if you calculate factored moment, okay, now we need to calculate the limiting moment of resistance. Mu limit we have to calculate. Okay, so again you have to see the grade of steel, which grade it is, whether it is Fe250, Fe415 or Fe500. So depending upon grade of steel, we can going to calculate mu limit. So mu limit, so for Fe250 grade steel, it is 0.148 FCK BD square, or if it is Fe415 grade steel, it is 0.138 FCK BD square. Okay, so depending upon the grade of steel, you have to calculate the mu limit. Okay, this is the second step. So after calculating this mu limit, right now you have the two values, mu from this and mu limit from this step. Okay, right now there are two values of mu and mu limit. Compare these two. Okay, so mu, if the first option is if this mu is greater than mu limit, okay, mu is greater than mu limit, then the beam is designed as doubly reinforced beam. So why we are checking here is, in the problem they will not going to mention doubly reinforced beam, just they will going to give the beam. Okay, they will not going to mention singly reinforced or doubly reinforced beam. If it is mentioned, then no problem. Okay, so if mu is greater than mu limit, then the beam is designed as doubly reinforced beam. Okay, right, then you have to calculate area of compression steel, ASC, which is provided at the top of the beam, ASC. Okay, so how will find ASC now? So find the value of if you want to calculate ASC, first you have to calculate FSC. Okay, find the FSC value as explained in type 1 problems, that is by referring the table F, SP16 code book. So from that, whatever the procedure we are used in the type 1 problems, so to find out FSC. So find the FSC. Okay, then we know that total moment. Okay, so mu minus mu limit. So mu is the total moment of the doubly reinforced beam. Mu limit is nothing but mu1 and there will be mu2. Okay, so mu minus mu limit means total moment minus mu limit. What it will give? mu2. Okay, so this term is nothing but mu2. So total moment minus mu limit is nothing but mu2. So what is mu2? Moment is equal to what? Stress into, okay, or force into perpendicular distance. Force into perpendicular distance. So force is FSC, okay, into ASC. FSC into ASC is force into perpendicular distance is d minus d dash. So moment is equal to force. This is a force. FSC into ASC is the force into perpendicular distance. So this is mu2. Okay, so mu minus mu limit is equal to FSC into ASC d minus d dash. So from this you can find out ASC. So therefore ASC is equal to, okay, mu minus mu limit divided by FSC into d minus d dash. Okay, mu is calculated from this. Okay, mu limit calculated from the second step. Okay, FSC we have calculated here. So substitute all the values, we will going to get ASC, that is area of compression steel. Then in fourth step, right, the area of tensile reinforcement we have to find out, that is AST. Okay, steel provided at the bottom. Okay, so how we'll find out again this? Okay, equate forces in the steel as well as in the concrete. Okay, so 0.87 Fy AST1. Okay, so this is a force stress is 0.87 Fy, area is AST1, that is under reinforced beam. So 0.87 Fy AST1 is equal to 0.36 FCK B into XU max. Okay, we have to find out, you have to consider here XU max, not XU. Okay, 0.87 Fy AST1 is equal to 0.36 FCK is the stress into area is B into XU max. So total tensile force equal to total compressive force. So T is equal to C. Okay, so what we want? We want AST1 plus first. So AST1 is equal to 0.36 FCK B into XU max divided by 0.87 Fy. So not this AST. So AST1 is equal to 0.87 Fy only. Okay, don't consider this. AST1 is equal to 0.36 FCK B into XU max divided by 0.87 Fy. Only this. Okay, cancel this AST1. So we can get AST1 here. Okay, then again total AST is what? AST1 plus AST2. Then how will find AST2? Again same, 0.87 Fy, AST2 is equal to, now the steel beam now, FSC into ASC. Okay, so from this we can find out AST2 is equal to FSC into ASC divided by 0.87 Fy. Okay, so after calculating AST1 and AST2, add these two, we'll get the total AST that is provided at the bottom. So total tensile reinforcement AST is equal to AST1 plus AST2. Okay, so we can calculate AST. So remember, there will be 4 steps. In the first step, if the moment is not given directly, if the load is given, span is given, then calculate the bending moment, maximum bending moment M, depending upon the end conditions. So multiply this 1.5, we'll get MU, that is factored moment. So once if we get factored moment, then the second step will be calculate MU limit. Okay, so compare MU and MU limit, see that whether it is a doubly reinforced beam or not. Okay, so if MU is greater than MU limit, it is doubly reinforced beam. Then third step will be calculation of ASC, that is area of compression steel. Okay, so MU2, that is MU minus MU limit, is equal to FSC into ASC D minus D dash. Okay, that is force into perpendicular distance. So moment is equal to what? This is moment, no, MU2. MU minus MU limit means MU2 is equal to, moment is equal to force, this is a force into perpendicular distance. So force is what? Stress into area. Okay, so we'll calculate ASC. Then in the fourth step, AST will be calculated. Okay, first calculate AST1, then calculate AST2. Add these two, we'll get the total AST. So the 4 steps you have to remember for type 2 problems. Okay, so in the next class we're going to solve the problems on type 2. Okay, so thank you very much for attending this session. Okay, so next class we'll solve the problems of type 2. Okay, so thank you very much for attending this session. Thank you.